And here is question number 21. The polynomial g of x equal to 2x cubed plus 3x squared plus qx minus 1 has the same remainder when divided by x plus 2 and x minus 1. We're asked to find the value of q, which is the coefficient of x. So to find the remainder by dividing a polynomial by a binomial, all you have to do is to take that binomial, set it to be equal to 0 and solve for x. Once you set this to be equal to 0, solve for x, that will give you x equal to -2. Take that -2, plug it here. Whatever you obtain is said to be the remainder. So we are going to plug in -2 into g. So wherever we have x, we are going to replace that by -2. So we have 2 multiplied by -2 to the power of 3 plus 3 multiplied by -2 to the second power plus q multiplied by -2 minus 1. You see that? So what do we need to do? Simplify. -2 to the power of 3, that will give you -8. -8 times 2, that will be -16. -2 to the power of 2 will be +4. Times this will give you 12. This is minus what? 2q minus 1. This and this will give us what? -4, right? And -4 minus 1 will be -5. So this together will give us -5 minus 2q. And this is said to be the remainder. We're going to do the same thing for this one. If you set this to be equal to 0, x will be +1. Plug it into g. G of 1 will be equal to 2, 1 to the power of 3 plus 3 times 1 squared plus q times 1, then minus 1, right? 1 to the power of whatever is still 1. So this is 2. This is 3. That is 5 minus 1 is 4, then plus q. So this is 4 plus q. But they said that they have the same remainder, which implies that this must be equal to that, right? Which implies that 4 plus q is equal to -5 minus 2q. If this crosses over, it becomes positive 2q, and we have a q here, making 3 q's. If this crosses over, it becomes negative. We have -5, -4, that's -9. -9. And by dividing both sides by the coefficient of q, -9 divided by 3 is -3. And finally, q equal to -3. Do we have it here? Yeah. Option C. Let us move on to question number 22.